Hey, I'm Brandon Arvon.
I'm James O'Malley.
Eric McDonough behind the camera, and this is our physics project. Today, we're going to show you how to hit a baseball using projectile motion, and
Newton's first law with momentum.
This is physics.
Go.
Now, I bet you're wondering who I am. I'm Chris Slade. Now, first they asked me to do this, so like, no way, not do it. You're going to have to pay me to do this. But then I thought, that's not the Christian thing to do. So lo and behold, I showed up. Got this sweet Jeep right here. It's like, y'all going to have to hook me up with one of these for being on your TV show. And they were like, no way, man. It's like, you know what? Screw you. I'm done.
So we're gonna have Brandon in the back of the Jeep here, tossing up balls, and we're gonna see what happens. And then we're gonna put a monkey on the hood and slam the brakes, and momentum will do its job.
okay,
Go.
you guys just saw us throw the balls in there. You know, that was pretty cool. Mr. Cucuzzello tried to tell me that the ball would stay. Now I believe him. He's right. He's good. He's good. Now, we're going to take this monkey. We're going to put him on the hood of the car. And we're going to show you that Newton's laws say that he's going to fall off when we slam on the brakes. It's about to go down.
It fell off. Go.
Okay, so we're out here, beautiful Blakefield Stadium, where we went pretty far this year. Played a great game.
This is where the ball team plays.
Yeah,
Might want to write that down.
write it down. Today, we're going to have one of the greatest players I've ever seen, ever got to play with. He's the man. He's going to show you projectile motion. About to put a ball over them trees right there.
Got this gas can here. Not sure what that's for yet, but you'll find out later.
Here we go.
Alright, go ahead.
I'm going to strike you out, son. You going down.
Brandon, you play ball like a girl.
Get in there.
Let me show you some projectile motion.
Bang! Man, I got some numbers.
Physics. Newton's first law states that an object at rest will stay at rest, or an object in motion will stay in motion unless acted upon by other forces. And we saw that in our first project when we threw the tennis ball in the air. Since no force greater than a tennis ball was acted upon on the tennis ball, it fell back into the Jeep because of the momentum which the tennis ball had. The only force acting on it was air resistance, but the momentum was so great that it just came back down into the Jeep. And the same thing happened with the basketball when we threw that into the air.
Precisely.
Also, Newton's laws worked with the monkey, because as you saw, since the car was in motion, causing the monkey to be in motion, as soon as the car stopped,
Yep.
the monkey stayed in motion and caused the monkey to fly forward onto the ground. Then
That's
being
right.
Run over by the Jeep. 'Cause the Jeep started going afterwards.
One word. Momentum.
Momentum.
And finally, in our third demonstration, where Brandon was pitching to James, since the bat had a greater velocity and a greater force than the ball went into the opposite direction and in projectile motion. Since the y velocity does not affect the x velocity, the ball flies through the air in an arcing motion.
You know what?
Physics.
This is not extreme enough. I'm sick and tired of this. We're about to go hard.
Yo, where you going?
No, don't worry about it.
Hey, where you going, man?
Yo, Adrian!
This is about to get weird, folks.
Man, why do we even have 3 bottles of this stuff?
Does
Come
Mr.
on.
Caney know about this?
I don't know what you're doing with that.
We're about to do some extreme physics.
Yeah, we are. This is Blakefield.
Due to the graphic nature, we could not show what happened next, but it was extreme physics. Speaking of projectile motion, watch this.
So what we did here today, kind of dangerous, you know, driving Jeeps, running over stuffed animals, hitting baseballs. But as you see, we took the precautions, got our helmet, got the screen, we wore our seatbelts, we did it right. That's how you do physics.
Don't do this at home, please.